Bismillahirrahmanirrahim. Momentum and Newton's second law of motion. And this momentum, the relationship between the momentum and the Newton's second law of motion is also known as impulse. What is impulse? Impulse is actually the change in momentum. When the two bodies involved in collision or two bodies collide, there are always some forces which the bodies act upon each other. And when a force is applied on some body, then according to Newton's second law, an acceleration is produced. Means change in velocity occurs. And what this change in velocity causes a change in momentum, and the change in momentum is known as impulse. But impulse is a specific name of a relationship that is actually a mathematical relationship between the force and the time. If the force is multiplied with the time, then the answer will be known as impulse. Initially, we described that the change in momentum is impulse, and now we claim that force into time is also impulse. In the next slide, we will see the mathematical verification of this description that impulse is actually the change in momentum and impulse is also the product of force and time. The unit of impulse is Newton into second, as it is the product of force and time. Now we see the mathematical verification of the description presented in slide 1, that impulse is the actually change in momentum, or it is a product of force and time, and it is derived from the Newton's second law. We know that acceleration is a change in velocity per unit time, and also Newton's second law of motion gives the relationship that acceleration is equal to force over mass. So from the above two relations, the right hand sides are equal, means F over m is equal to Vf minus Vi over t. If we cross multiply, then F cross t is equal to mass into final velocity minus mass into initial velocity. This force into time is named as impulse, as we have already defined that the product of force and the time should be given the name of impulse. So, and it is proved that this is mathematically equal to change in momentum or delta P. So, in the future, students, you will say that the product of force into time is equal to change in momentum, and the product of force and time is named as impulse. If I say impulse is equal to change in momentum, then it's correct. Conversely, we say that if t becomes in the denominator, then force is equal to rate of change of momentum. From equation 3.11, if time is taken to the denominator on the right hand side, then this equation will be resulted, and this shows that force is actually the ratio of change in momentum to the time. A rate of change of momentum is equal to force, and you see ratio of velocity over time as given in the initial equation, is known as acceleration. So F is equal to m into acceleration, ma is in Newton's second law. So we have conversely proved the Newton's second law from the equation of impulse. Increasing momentum over a long time. As we know that, as we have defined that, change in momentum is equal to impulse, and impulse is a product of force and the duration of impact. This duration of impact, if this duration of impact is increased, then it means that momentum, the change in momentum will be increased or the impulse will be increased. So if you have a smaller force, but you want to change the momentum of a body too much, then you have to apply that force, smaller force, for a long duration of time. And after long duration of time, the speed of that body will increase and the momentum of the body will increase. So the change in momentum will occur. More change in momentum will occur, or the more will be the impulse. So for increasing the momentum over a long time describes that with a small value of force, you have to apply that force for the long duration of time so that the change in momentum occurs. Similarly, if you have a bigger force and you want to apply a change in momentum, then you should apply that force for a very short duration of impact. Thank you, students, for watching the video, and please visit the www.cancollege.com for more information.